The plants grew and absorbed the sun's energy. As the plants died and fell into the swamp, new ones grew in their place. And when these died, still others grew. Well, as the years went by, a thick layer of dead plants accumulated at the bottom of the swamp to form a spongy brownish material called peat.
And this is a piece of peat. It's very soft and crumbly. You can still see some of the plant remains in the peat.
As sea levels changed and rivers flooded, sediment covered the peat. As layer upon layer of sand, mud, and clay piled up, the peat was further compressed by pressure and heat, squeezing out most of the water. As if in an oven, layers of peat were cooked until after millions of years, they hardened to what we call coal.
Plant material has a lot of carbon in it. It's an organic material, just like anything. And when we heat that plant material, the carbon turns black. And the same thing if you heat wood in a fire, you take a piece of wood, burn it, it'll turn black.
There are 4 major types of coal that are classified by hardness. The harder the coal, the less moisture it contains, and the hotter it burns.
We have the next one here. It's a piece of sub-bituminous coal. And there's still some little brown and yellow flecks in there, but you can see it's starting to get shiny. And this is the coal we have in Kentucky. It's called bituminous coal. You can see it's very shiny, and there's many layers in it. And then the last stage for coal, when it's heated under intense pressure, would be anthracite coal. And you can see it's very shiny, and it's very hard. The hardness comes from the pressure, and that you're continually putting these things under more and more pressure as you bury them through time.
Today, coal is found in 38 different states. But we're here to learn why coal is found in Kentucky.
We know what the rocks look like at the surface, but we want to know now what they look like underground to help explain why the coal is where it is. So imagine we take a knife and we cut through Kentucky, and we look at how the rocks are layered beneath the surface. And what we can see is this gray area here, the Western Kentucky coal field. Places like Hopkins County, Webster County, Henderson County. The gray occurs in a bowl here. Gray rocks. That's the rock that has coal in it. And all of the rocks kind of dip in that area. It's what we call the Illinois Basin. We go towards the east into central Kentucky, Fayette County, Jefferson County, and we see that we don't have that gray rock anymore. It's gone. It's been eroded. And the older rocks, these purple rocks, are pushed up to the surface. We go back into eastern Kentucky, counties like Breathitt and Knott, Perry, Pike County, and we get the gray again. That's the coal-bearing rocks. And that's called the Eastern Kentucky Coal Field. It sits in another depression that we call the Appalachian Basin. So basically we have 2 bowls that filled up with coal-bearing rocks. And then we have an area in the center of the state, which we call an arch, where the rocks have been eroded.
In East Kentucky, coal is found in a 37-county area. In West Kentucky, coal is found in a 19-county region. Kentucky coal seams run from 2 feet to 8 feet thick, and the distance underground varies widely.
Bituminous coal basically means that's the rank of coal, the rank of the plant material, how hot it's been heated, how much time it's been underground, how much pressure it's gone under. The coal in Kentucky has been in the ground for 300 million years. It was buried by thousands of feet, if not miles of sediment, and that has been eroded. And all that pressure and time heated it to the point where it is now bituminous coal.
Kentucky still has a lot of coal in the ground, over 91 billion tons, and only 14% of Kentucky's coal has been mined over the last 170 years.
Welcome to this video. C.2 fossil fuels were formed by the reduction of biological compounds that contain carbon, hydrogen, nitrogen, sulfur, and oxygen. So a little bit of a mouthful. Let's start off with the most abundant fossil fuel, and that is coal. It is by far the most abundant fossil fuel, and the reason why is it was formed by the remains of plant life about 300 million years ago. That's a Carboniferous period. And what happened was those trees would die and collapse, and eventually layers would form, and it would start to create intense pressure, sort of getting everything stacking on top of each other. Increased pressure also makes things get hotter. So intense heat pressure, and then the fact that once you get layered under something, there's no air exposure. We call that anaerobic conditions. So what happens is all of that material is now decaying without oxygen, and there's some bacteria that do this decomposition. And those bacteria produce a sulfur compound called hydrogen sulfide. And that's important because sulfur is a major sort of component of coal that makes coal produce acid rain when it is burned, because it releases sulfur into the air, and that comes from this process of anaerobic decomposition. So this is sort of the process that happens. We start with these layers, like we said, of plant material, and so we can see here sort of those initial layers. It's kind of wet, it's kind of moist at this point, so we call it peat. Now, after a little bit of time of being exposed to that pressure and increased heat, it gets a little bit harder, and we call that lignite. And what's happening again is it's decomposing, and as it's doing that, it's actually losing some oxygen, and that's what reduction means. It's sort of the opposite of oxidation, which is adding oxygen in. This is reduction, the fact that they're actually losing oxygen. Because if we step back and we try and think about how plants actually grow and are made, most of the mass comes from the CO2 of the air that the plants take in and the water that they bring in through the atmosphere, mostly through the roots. And we end up creating the parts of the bodies of the plants that are made of carbon, hydrogen, and oxygen. And of course, there's other ones with nitrogen and sulfur. But sulfur is not as much. Nitrogen is in the proteins. And eventually, as we go through this process, these oxygens are eliminated, which is reduction. So as we go along, that's what's happening. Our next step there is bituminous soft coal, and that one again getting harder, less oxygen in it. And the last version is anthracite. And if we were to actually follow the transition, what would happen is the amount of energy we could actually get from each of these will increase. So anthracite would release more energy per gram than the ones before. So let's contrast that a little bit with our next one, which is crude oil. So crude oil is the liquid form. It's not solid like coal. And it's not only used as a fuel, but as a chemical feedstock. So we often say that oil runs our modern civilization in more than one way, and that other way besides energy is the fact that it produces our plastics. Our plastics come from crude oil. And if you could just try to look around your room right now and see how many things you own that are made of plastic, you can see why it's so vital to modern life. So this was also formed over millions of years, but instead of being from trees like coal primarily, we have it from marine animals and plants. And they had the same idea after that, is they were trapped under layers of rock, and then we have those conditions of high temperature pressure, and again the anaerobic conditions, a lack of oxygen. So eventually the oxygen leaves again, which is reduction, and we end up in the end with hydrocarbons. And hydrocarbons meaning that they're mostly carbon and hydrogen. So this is like propane that you would have in a barbecue, butane like in a lighter. All of those were formed as a result of the loss of oxygen. Now, one interesting thing to note again is because we have this anaerobic bacteria producing hydrogen sulfide, we have to actually refine crude oil before we burn it, because sulfur actually interferes with catalysts that are used in later processes, for example in creating different fuels or our different materials